Today we're going to talk about the quadratic equations using complex numbers and then complex numbers in general. So first what we're going to do is learn about what a complex number is. Okay, so an imaginary number is also called a complex number. When you have a negative underneath your radical, you have an imaginary number. So you can't have the square root of a -1. So anytime you have a negative, you take out an I, which stands for imaginary. So the square root of -1 would just be I. If you have the square root of -5, like in our other example, the I would come out, and then it makes whatever's in the radical now positive. So square root of 5 is staying inside, but I comes outside. So if we want to simplify these square roots, we're going to simplify them like we normally would if they weren't negative. So the square root of -7. If I take the square root of 7, it can't break down, so it's just going to stay 7, but the I is going to come out. And because they're square roots, we're going to take plus or minus for each. So it's going to be plus or minus I square root of 7. For the second one, we have the square root of -36. Well, if you take the square root of 36, that's just 6. So it's going to be plus or minus 6i. Anytime that there's a negative inside the radical, we're just taking out the I. So when I have the square root of -12, well, if I had 12 and I break it down with my tree, I have 4 and 3 and 2 and 2. So I would have 2 square root of 3. That's if the 12 was positive. So it's the same idea. I'm just going to take out the I. So it's going to be 2 plus or minus 2i square root of 3. So the I just gets tacked on to the outside of the radical. Okay, when we're adding and subtracting, we're just combining like terms. And in this case, the like terms are the real parts, and then the other like terms are the imaginary parts. So if we look at the first example, the 7 and the -3 are like terms. So I'm going to add 7 plus a -3, and I'm going to get 4. Okay, then I'm going to take the -2i, and I'm going to add it to the I, and I'm going to get -i. Okay, so 4 minus I. And if we look at the second one, again, we're going to take the like terms, so -3 and +3, they're going to cancel out. 9i plus 9i is going to be 18i. And with subtraction, just make sure that you are distributing your negative. So if you want to, you can rewrite it. So if you want to rewrite it as 8 plus 6i, make that a plus, and then change that to -8 plus 6i. You can. It's just you're distributing the negative first, whichever one you want to do. So again, we're going to compare the like ones. We're going to take 8 and 8. So 8 minus 8 is 0, so that's gone. 6i minus a -6i becomes 12i. Okay, so make sure you distribute your negative to both. Okay, and the last example on this page, again, like terms. 1 minus 3 is going to give me -2. 5i minus a -2i becomes a positive 7i. And there's our answer. Okay, when we are multiplying, we want to distribute and FOIL like we normally would. But there's a special rule here. Anytime you multiply an I times an I, it's equal to -1. Now the reason for that is that we know I equals the square root of -1. That's what I equals. So if I do I times I, right, I'm really doing I squared. So I squared is going to be the square root of -1 squared. And we know that if we take the square root of something that we're squaring, it's just going to be the number underneath the radical. So the square root of -1 squared is just going to be -1. So that's why I squared is -1. So you should never have an I squared. Anytime you have an I squared, replace it with a -1. So if we look at this first example, 7i times 3i. So we're going to multiply the 7 and the 3, so that's 21, and times the I is going to be I squared. Okay, we can't have an I squared, so we're going to replace that with the negative 1. So our answer is now negative 21. Okay, the second one, we're going to FOIL. So we're going to do 2 times 4, so we get 8. 2 times 5i is going to give us 10i. Negative 3i times 4 is going to give us negative 12i. And negative 3i times 5i is going to give us negative 15i squared. Okay, so again, we don't want to have the I squared, so we're going to just rewrite this. So I can combine these two right away, and that's going to give me negative 2i. And now I have negative 15 times negative 1. So I'm just replacing that I squared with a negative 1. So this becomes 8 minus 2i plus 15. And now I can combine the 8 and the 15. And I'm going to get 23 minus 2i. So it's okay if your answer has an I in it, you just can't have an I squared. Okay, so we're going to do the same thing now for the last one. So we're going to distribute. So we're going to do negative 4 times negative 4 is 16. Negative 4 times negative 5i is positive 20i. 5i times negative 4 is negative 20i. 5i times negative 5i is negative 25i squared. So now we have the 20i and the negative 20i. They are going to cancel out. That'll just become 0. So now we have 16 minus 25. And instead of I squared, I'm going to put in a negative 1. So what I have is 16 plus 25, which is 41. Here are some that you can try on your own. So adding and subtracting and multiplying. Okay, I will do these for you guys. You have your answers. So again, combine like terms. Oops, that's not 8 and 6. Sorry, 6. 4i and negative I is going to be 3i. Okay. You're subtracting, so make sure you distribute your negative. Negative 6 minus 1 is negative 7. Negative 7i minus 3i is negative 10i. We're going to FOIL the third one. So that's going to give me negative 6 minus 18i minus 5i minus 15i squared. So negative 6, these will combine and give me negative 23i. And then instead of I squared, I'm replacing it with a negative 1. So now that is really a positive 15. So a negative 6 minus 23i plus 15. That's going to give me 9 minus 23i. So make sure when you're writing these that the number goes first and then the I goes second. Okay, and the 9 plus 4i squared. Be careful with this one. Okay, you're not going to distribute your square. You're not going to do 9 squared and 4i squared. There's 2 9 plus 4i's. So we're going to write it twice. So 9 plus 4i times 9 plus 4i. And distribute, so 81 plus 36i plus 36i plus 16i squared. So again, I can combine these together. So I have 81 plus 72i plus 16 times negative 1. So 81 plus 72i minus 16. Since I have 16 times negative 1, combine our like terms. And now I have 65 plus 72. So we did adding, subtracting, and multiplying with complex numbers. When we are dividing complex numbers, we have to use the complex conjugates. And what that means is that you're going to change the sign with the binomials. So sign with binomials. remember when we had to rationalize the denominators with radicals? You want to multiply the bottom by the square root to get rid of it. Well, here we don't want to have i's in the bottom. So in the first example, for b, we're just going to multiply by I. We want to get rid of the I. So I over I. So we're going to distribute this. So 4I minus I squared. And on the bottom, 6I times I is going to give me 6I squared. We know that I squared has to be replaced with negative 1. So we have 4I minus a negative 1 on top, and then a 6 times a negative 1 on the bottom. So we're going to have the number first, so 1 plus 4I over negative 6 as our answer. If you don't want the negative in the bottom, you can just switch your signs and make it negative 1 minus 4I over positive 6. So I'm going to put 4 here. Okay, so either one of these is an acceptable answer. Okay, they're both equivalent. For the second one, because you have a binomial in the bottom, you have the 3 plus the 4i, we need to multiply by the complex conjugate. So that means I'm going to multiply by the bottom, except I'm going to just change the sign. So instead of 3 plus 4i, I'm going to multiply by 3 minus 4i. 3 minus 4i. Okay, top and bottom get the same thing. So all I'm doing is I'm just changing that sign. So now we're going to FOIL the top. So 5 times 3, I get 15. 5 times negative 4i, I get negative 20i. Negative 2i times 3 is negative 6i. Negative 2i times negative 4i, I get plus 8i squared. And on the bottom, because I changed that sign, this is kind of like when we did difference of squares. If I multiply 3 times 3, I get 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. 4i times negative 4i is negative 16i squared. So when we multiply by that complex conjugate, what happens is our I term in the bottom cancels out. So those are going to cancel out, and then we can replace all of our I squareds with negative 1. So on the top, I'm going to have 15. I'm going to combine those together and get negative 26i plus 8 times negative 1 over 9 minus 16 times negative 1. So I'm just going to change the 8 times negative 1 to a negative 8. So 15 minus 8 is going to give me 7. And then I have minus 26i. And on the bottom, I have 9 plus 16 now.